Good morning and greetings, friends of chemistry. Martin and I are doing the review questions for Module 12. Martin will read review question 1.
Define pressure and name 3 units used to measure it. Pressure equals force over area of force exerted on.
Pressure is
Force
divided by what?
By area.
By the area. What area?
Of effect.
The area the pressure is exerted on?
Yes.
Okay. What is the second part?
3 units of pressure. So there's the torr, there's the atmosphere, and there's the Pascal.
How do you abbreviate torr?
Just you don't.
That's right. How do you abbreviate atmosphere?
It's ATM.
How do you abbreviate Pascal?
P.
No.
Oh yeah.
PA, right?
PA.
Okay. Is that it for number 1?
Yes.
Okay, number 2. Write
Boyle's law in your own words. Boyle's law is.
Where is it defined? What page is it defined in the text?
It's on page 384.
Mm-hmm.
As long as the temperature of the gas stays the same throughout the experiment, the product of a gas's volume and its pressure is always the same. In mathematical terms, pressure times volume equals constant.
Okay. So, at the same temperature.
Did I say pressure instead of temperature? Because that's what I meant to say.
I think you read it correctly. And at the same temperature, the product, these multiply, right? Of a gas is what?
Volume.
Volume times
pressure.
I started writing pressure already, so I'm writing pressure times volume. Is a constant.
Yes.
Okay, so that's how I would write it in my own words. Do they accord with your words?
Yeah.
Good. Is there a second part to this?
No.
Great.
Which of the laws you studied in this module leads to the Kelvin temperature scale? Well,
I'm not sure how that's phrased. Leads to.
Like, I think it means you have to use it in Kelvin.
Or which
but
one
we're supposed
results
to use all of them in Kelvin, all the temperatures in Kelvin. So I'm
all of the gas laws, right?
Yeah.
All of the gas laws that we studied in this module.
Yes.
Require working in Kelvin. So that's a really important thing to remember, because if you do all the work correctly, but you're not working in Kelvin units, you're going to get the wrong answer. It will look right to you possibly, but it won't be right because you're not working in Kelvin. Okay.
Yeah.
Number 4 says, what general rule must a careful scientist...
Incorrect. We got it wrong. The Kelvin temperature scale derives from Charles' law.
Oh, I understand.
Was his last name Kelvin?
We didn't. Which of the laws that you studied? No. Okay, leads to it. All right, so where is Charles' law defined?
It's
Sorry, I misunderstood the question.
Boyle's law.
Okay, so on page 389, okay, we see Charles's law. Charles's law says that volume 1 over temperature 1 equals volume 2 over temperature 2, right? And if you graph So if you look at figure 12.3, right, you see the effective temperature on volume of the gas at constant pressure. Where do all these lines appear to be originating, Martin?
At negative 273.15 degrees Celsius.
Okay, I misunderstood the question. I thought they were saying which one do we have to use Kelvin in. So Charles' law, you can see the graph on page 385. Okay, where you see the line showing that the effect of temperature on pressure, right? I mean on volume, leads you back extrapolating extrapolating the data of the effect of temperature on volume leads to 273.15 negative degrees Celsius, right?
Yes.
And so we make that equal to 0 Kelvin, right?
Yes.
Okay, so that kind of leads to question number 4. Question number 4 asks us, what general rule must a careful scientist follow when extrapolating data? So on page 390, there is a discussion of that. Okay? So the careful scientists will only make a small extrapolation based on data, not a large extrapolation based on a small amount of data. So careful scientists will be wary of extrapolating too much data. Extrapolating. Sorry for squeaking. Make sense? Any questions about that?
No.
Okay, we're going to pause here and come back with another video for 5 and onward.